trying to simulate the setup we had.
The original code is based on the 2015 symposium, but we found the correlation estimation problem at the 2017 Hamvention last year.
Okay. So over on this computer, we're transmitting the symposium demo waveform, which is a time division multiplex of 4 different voice-coded signals.
FDM up, TDM out.
And it should be generating a waveform that looks like this.
GNU Radio, and here is the USB cable. It goes all the way over to this USRP, which is transmitting a signal through this antenna to this antenna, and we are checking it with this spectrum analyzer, and there you go. So we are actually transmitting the TDM signal. So here, this particular computer is also connected to an SDR. So I'll just show you that it's this. So it's a HackRF on this particular computer. So what we're trying to do is run all this stuff over the air. Here's the antenna for that particular one. In general, we try very hard to run everything over the air. It's more of an acid test for this sort of thing than to run a flow graph within the same computer. What we found is that if you have everything running on the same computer, it's easier, right? So if you have to run everything over the air, well, it just gets you a lot further down the road.
So this here is the data that's being transmitted, where one horizontal line represents one whole superframe of all 4 channels. You can see it's nicely systematic. These vertical lines represent the guard times between the individual channels, and each one of these channels has a pattern that's depending on the codec. Over here is where we're trying to reconstruct it.
Yeah.
You can see this has data in it. There's random looking data similar to what we see being transmitted, but it doesn't have the vertical structure. That just means that it's not synchronized in time, which is a result of the correlator part not working yet.
Okay, say something profound.
If we wanted to break this again in an educational way, we could update pi bombs on both systems and see what else has been broken out from under us. While we have a strong signal coming in, take a look at the preamble correlation window here. We've got a nice strong response every 5 milliseconds, which makes sense. That's the interval at which we're sending preambles. 20 millisecond voice frames, but we have 4 of them in parallel, so every 5 milliseconds. See how it's generating red spikes and blue spikes, both up and down? Well, that's probably not good. It indicates we're detecting the preamble, but not synchronizing to it, which is consistent with this data, which is still a mess. See, we're now actually receiving a recognizable waveform.
Yeah, this sort of looks like the thing that's on the spectrum analyzer. You do that. You know, like it's 2 Star Trek spaceships that are, trying to shoot each other. Well, then it doesn't look any good.
Hold them a little higher so they're against the white wall.
Okay.
I can't see them in the shadows.
Like that?
There we go.
All right, like, duel at dawn between 2 delta wings, that's what it looks like. But this doesn't really work very well, but if you do this, then, it looks great, works out.